Today, we are diving into one of the most annoying, tedious problems in all of cloud engineering. How do you stop your architecture diagrams from becoming useless, outdated pictures? We're going to explore a new way to do it, using AI to create automated diagrams that, finally, don't lie. Okay, so let's start with a problem that every single engineer has felt. I call it the diagramming dilemma. You're basically stuck with two terrible choices, right? You can draw everything by hand, which is super accurate, but takes forever, or you can automate it, which is fast, but you usually end up with a chaotic, unreadable mess that you have to go back and fix anyway. And yeah, because of this trade-off, most diagrams, well, they just die a slow death. They get drawn once, exported as a static image, and then they start to drift. Slowly but surely, they fall completely out of sync with the real system that's actually running, turning into artifacts instead of tools you can actually use. But what if we could finally break that cycle? Well, the first step is to start treating our diagrams like we treat our code. And that brings us to the first key piece of the puzzle, a technology called Drawio MCP. So what is Drawio MCP? Well, instead of you having to drag and drop every single little shape and line, MCP lets you generate a diagram from a structured input, like an XML file. This is huge because it turns diagramming from, an art project into an actual repeatable engineering process. And the benefits here are immediate. We're talking about incredible speed. You can get a working draft in seconds. You get consistency because the same layout logic is used every single time. And, maybe most importantly, you get repeatability. If you need to update the diagram, you just change the source file and regenerate it. It's perfect for plugging into your automation pipelines like CI/CD. But, of course, there's a catch. MCP is a generic tool. It's great at arranging shapes and lines, but it knows nothing about Azure. It has no idea what a virtual network is or why a firewall should sit in front of an app gateway. So what happens when this powerful but kind of dumb engine meets the very specific, very complex world of a cloud platform? This is where things get really interesting. To bridge that gap, we need to add some intelligence. We need a specialized skill, an agent that can teach our generic tool how to speak fluent Azure. And that is the Azure Diagram Agent Skill. Think of it as a portable skill for GitHub Copilot that sits right on top of Drawio MCP. Its entire job is to inject all that Azure-specific logic, all the rules and all the conventions directly into the process. The goal? To spit out clean, reliable diagrams that an actual engineer would look at and go, okay, yeah, I can work with this. So what does the skill really do? Well, it's laser-focused on fixing all the little things that most automated diagramming tools get wrong. The stuff that turns a potentially useful diagram into a confusing mess that makes you want to pull your hair out. It really zeroes in on three key things to make the diagrams better. First up, reliable icon handling, so no more broken images. Second, it uses a curated, validated list of official Azure icons, so you'll always get the right one. And third, and this is a big one, it applies a bunch of smart anti-clutter defaults right from the start. And here's how it keeps things readable. These aren't just random rules. They're based on how people actually read architecture diagrams. A max of 3 or 4 lanes to keep it focused. A primary flow that goes from left to right. Using simple numbers for stages instead of a million distracting labels. And, of course, minimizing those awful crossing lines. The whole point is to generate a diagram you can share with your team without having to apologize for it first. All right, enough theory. Let's see this thing in action. What does this look like when you throw a real complex Azure architecture at it? Does it actually work? So the creator of this skill put it to the test on a real project. And the big takeaway was this. The result isn't just a pretty picture. It's a team-ready architecture sketch. It's something you can immediately use in code reviews, for comments, and you can tie it directly back to your pull requests and your documentation. And look, this wasn't some simple Hello World app. We're talking about a secure API hub with a really complex flow. You've got traffic coming in through Azure Front Door and a WAF. It's passing through an application gateway, hitting API management inside of VNet, and then going to backends like app services and Kubernetes. All of that secured with managed identity and Key Vault. And the skill handled the whole thing, automatically applying the right Azure icons for every service. So here's the really crucial point. This whole approach, it fundamentally changes what a diagram is in the development process, especially as we move deeper into this new world of AI-assisted everything.
Because when your diagrams are fast and they're reliable and they're accurate, they stop being these stale, static images that nobody trusts. They become a living, breathing part of your engineering process, just as important as your actual code. And this unlocks a brand new, crazy fast workflow. I mean, imagine this. You just start by telling an AI agent what you're trying to build, your architectural intent. The agent then uses this Azure skill to instantly generate a visual draft. From there, you and your team can just focus on validating the layout, the icons, and the patterns, iterating and refining at a speed that was just impossible before.
And it's so important to get the ultimate goal here. The point is not to get rid of drawing or to replace human expertise. It's all about drastically reducing the friction between the idea in your head, the system's intent, and a clear visual diagram that your entire team can actually understand and build on. And that leaves us with one final, really powerful question to think about. If your architecture diagrams could just keep themselves up to date, perfectly reflecting your real system all the time, what could you and your team build next? What new level of innovation is suddenly possible when all that friction is finally gone?